So we're going to continue 5.2 and 5.1, sorry. And again, the question is really when do you stop? I'm trying my best to just getting you used to rewriting things in terms of sine and cosine and just getting it so the expression that you start with looks nicer at the end. And you can double check that you have the right answer with the use of a graphing calculator. But if you say, hey, I got my answer by looking at a graph, by looking at a graphing calculator, you will not earn any points. So again, it's very tough to know when to stop. When we get to the next lesson and the third lesson, I'll tell you when to stop. I'm going to tell you what I want the left side to simplify to, because there will be a right side that it equals something. But we're just practicing right now. So the very first thing, as was my advice in the first video, is to rewrite everything in terms of sine and cosine. So tangent, I'm going to rewrite that as sine over cosine. Again, you have to write sine of theta over cosine of theta. I know it probably seems like a hassle, but you should. Now, this is where your work might differ from mine, because some students like to add fractions together, and I'm all for that. You just don't have to. Because as I'm looking at this, I would distribute this cosine in. That's just my way of doing this, because I see that cosine over cosine would cancel. So I would get sine of theta, plus here I would get cosine squared of theta over sine of theta. Because remember, cosine of theta times cosine of theta is cosine squared of theta. So now what I need is I need to get my denominators to be the same so I can add these together. Well, this sine of theta is fine over here. I just need to make sure that I have another sine of theta on this side. I can't just randomly throw in a sine. I also have to multiply the top by sine as well, which would give me sine squared. So why on earth would I do that? Why is this a simplified version of up here? Because I'm adding something. Well, now I can combine sines of theta together because the denominator is the same. And in the numerator, I have sine squared plus cosine squared. Well, if I go back one page, I know that sine squared plus cosine squared always equals 1. It would be to your benefit to memorize that. Now, some people will stop right there. And I get why you would stop. But I would take it one step further, because the reciprocal of sine is cosecant. And that is less writing than this. So, very difficult to know when to stop. And I get it. When do you stop? My biggest suggestion is to just continue on until you have the least amount of writing. And that's not necessarily the best advice, but that's what I'm going to go with. And for the record, I do have answer keys. I don't always use my answer keys, though, because your answer key might have completely different work than mine. That doesn't mean you're wrong. You just worked it out differently. So when I make my quizzes, when I make my tests, I usually make an answer key just out of habit, but it doesn't necessarily mean anything to me. So moving on to the next one, the bottom left here, I'm just changing colors and working forward, is a lot of students get stuck. Where do I start? And that's where good advice comes in, where students will just rewrite everything with sines and cosines. I want to be a little bit more adventurous than that. Because in the numerator, I see secant squared and tangent squared. Well, I know there's a Pythagorean identity. Let me go back a page. Dealing with tangent squared and secant squared. So you can just pick one of these. I'm going to pick secant squared. And I'm going to replace secant squared in that equation with 1 plus tangent squared. So over here, I'm just picking the secant squared, and I'm going to replace that with 1 plus tangent squared. I'm going to leave everything else alone. Oh, whoops, it was x. These variables are just variables, by the way. You do want to keep the same variable throughout. So that was a bad thing on my part that I randomly put back theta in the problem. But anyway, Once you have that, I'll switch back to orange since I had that, you can see that tangent squared minus tangent squared will cancel. And so I'm just left with 1 over cosecant. I can see why somebody would stop right there. But cosecant's reciprocal is sine, just like what we did up here. So this answer actually just simplifies to sine of x. And before moving on, I do want to point out that you can check that your answer is right before moving on. And that's with the use of a calculator. So if I go to a calculator and, I'll just, I know we haven't done this yet. That's the graph of sine is this curve. It looks like this. But what I'm saying is if I were to give you the other equation, which unfortunately it's such an ugly fraction and we don't even have a button for secant, so I would have to have a fraction inside of the fraction. Secant is 1 over cosine. Where's cosine of x? Squared was minus tangent squared. Hopefully I'm typing this in correctly. And then divided by cosecant, so that would be 1 over sine of x. And if I go to the graph, what should happen if I did this correctly is that red curve will cover up that blue curve. And that is exactly what's happening. So I know before turning in my work that I have the correct answer. Now the graph is not proving anything. It is not showing the work that leads to the answer. It is double checking though. You might also notice that there's a hole right here at x equals 0 because, we're dividing by 0 there. So there are domain issues, but I'm not worried about that today. So moving forward to the next one, again, a good piece of advice, and I agree, it is a good piece of advice, that you could rewrite these in terms of sines and cosines. But as I'm looking at this problem, I also noticed that we have 1 plus cotangent squared. And I swear in the previous page, we had a trig identity that said 1 plus cotangent squared is equal to something. And it's right here. 1 plus cotangent squared is equal to cosecant squared. So I'm just going to substitute there. 1 plus cotangent squared is equal to cosecant squared of theta. Well, we have a cosecant on top. Now, a quick mathematician would look at this and say, oh, well, we can cancel out one of those cosecants. I'm not sure if all of us are there yet. So let me just remind you that cosecant squared is the same thing as cosecant times cosecant. So really what's happening is we are just canceling out one of those. That's what I mean by that. So our answer, not completely simplified because I would take it one step further, but again, when do you stop? Is 1 over cosecant is equal to sine. And make sure you say sine of theta. If for some reason you just randomly drop your thetas, at least in your homework, I'll probably just make a note like, hey, don't forget to write theta everywhere over and over again. Because I would hate for you to go to college and your college professor takes off 50 points because you just dropped the theta, but all of your knowledge was good. But who knows how I will grade your test. On your test, I will probably not just make a comment. I will probably take a few points off. You have to write theta or x or anything, whatever the variable is. So moving on, again, there are so many different ways of showing the work to lead to the answer. Okay, and again, the quicker you memorize the trig identities that we started with, the better. Because as I look at this, the first thing that shouts out at me is 1 plus cotangent squared. And in case you don't have it memorized, 1 plus cotangent squared is equal to cosecant squared. So this piece, let me highlight it, is equal to cosecant squared. And remember the angle, it's just an angle. It's just a variable. You can change it. That's my alpha. Now I would go ahead and rewrite tangent as sine over cosine. rewrite cosecant as 1 over sine. But it's cosecant squared, so 1 over sine squared. And then cotangent as cosine over sine. Because now that I'm looking at this, I can cancel out one of these signs. So what I really have, I'm going to do 2 steps at once, so please stick with me, is I have 1 over cosine alpha sine alpha. And instead of dividing by a fraction, I'm going to multiply by the reciprocal. That's something you should know already. If you don't, I can quickly explain why that's the same thing. Is really what's happening, I'll do this in orange again, is I want to undo this thing, so I want to get rid of cosine over sine. So in order to do that, I need to multiply by the reciprocal of that. And the only way you can get rid of that in the denominator is if you also do that in the numerator. The same operation. And the reason why it's the same is because sine over cosine divided by sine over cosine is really multiplying by 1, because all of this is the same thing over and over again. And in the denominator, these things cancel, and these things cancel. So that's why this is the same as what we have over here. Let me switch colors one more time. Anyway, we're almost done, because now we could cancel out the sine of alpha, and we're literally left with just 1 over cosine squared. But I would ask you to take one more step, because some of you might stop right there, because I would just say, well, what's the reciprocal of cosine? And that answer would be secant squared of alpha. Whew. I hope you guys are understanding this. If not, you're going to have to bring questions to class. As we move forward, this time the directions actually tell you that you should get a single trig ratio, whereas the other one, maybe it did, maybe it didn't. But again, I would encourage you to, if you don't see anything squared, your best bet is to rewrite everything as sines and cosines. So secant's 1 over cosine, cosecant's 1 over sine, and tangent is sine over cosine. So we almost have the same, because we can just multiply straight across. We almost have the same denominator. The only issue is we'd have to multiply this piece by sine, and that's only okay if you also multiply the numerator by sine. So now what we have is we can put the denominators together, cosine theta, sine theta, and in the numerator you have 1 minus sine squared of theta. I hope that's all making sense. And in the first video we talked at a pretty good length about why 1 minus sine squared is equal to cosine squared. And in the denominator you have cosine times sine. And the reason why you should go through that step is because now you could cancel out one of these cosines, because there's 2 cosines on top, there's 1 on bottom, so you're just left with cosine over sine, which is equal to cotangent of theta. And I'm going to stop right here because I have several more practice problems, and I will see you in the next video.